Great. Okay, so from team 4, who's presenting? Sorry, did I say team 3? Team 3 is first.
I will be presenting.
Great, Brian. Okay, yeah, so if you can share your screen
okay,
with the presentation. And then again, please check the main Slack thread. You can see when the presentations are coming up, and you can maybe queue up your presentation. Okay.
So everyone can see my screen, right?
Great. Okay, thank you, Brian. This is for group 3, team 3, everybody, team 3. Thank you.
Hi, everyone, and thank you for joining us today. We are group 3, the Hollywood Hackers. Our data story is driven by true events. In 2014, Sony leaked 26.4 gigabytes of data, including 33,880 files, 47,426 social security numbers, 15,232 of which belonged to former Sony employees. Among the employees that were leaked included those that were private conversations stating that lead star of American Hustle, Jennifer Lawrence, was getting paid less than her co-stars. This resulted in millions of dollars that her male co-stars negotiated that she did not receive. This event sparked talks about pay inequality in Hollywood. So we wanted to ask the question about how inequity might or might not exist in ratings for movies. Our central hypothesis is for movies with a similar budget, genre, and movie length in a certain range of years, movies where the lead actresses are female got lower ratings than movies where the lead actors are male. So to do this, we began looking at the data set from the Movie Lens database. And what we found was that it was insufficient for our analysis. So we looked at API data from TMDB endpoints and obtained more data, which we called cast, and included the budget, the runtime, and whether the leads were male or female, which we identified by either 1 for female or 2 for male. We also initially were using the tags dataset, which we noticed has a long tail. We decided against using it because it was not relevant to our central question. And given the time constraint, we would have to make decisions on how the bias would affect our results. For our ratings, we use the aggregate of the mean of the ratings as a central rating. What we initially found in our merged dataset, which was about 265,851 rows by 8 columns, was that there were values that were outliers. For example, there was a documentary that was 15 hours long. We also found that a third of our data had a budget of $0. This allowed us to interpret what similar data would mean for our analysis. We looked at the spread of our ratings and noticed that most of the ratings were around the 3 or 4 star mark. We plotted a box plot and noticed that when we plotted gender against ratings in our dataset, the distributions were not significantly different. They barely changed besides on the lower end of the ratings, but even so, not to a statistically significant degree. We also looked at the correlation of gender to ratings and movie category and did not find strong correlations that might indicate a preference of one over the other. We decided to use the XGBoost ensemble classifier to determine whether, in fact, gender has a significant effect on mean rating. Ensemble methods are feature sensitive and interpretable. We found by looking at a SHAP model we created after we ran our XGBoost model that gender was not a feature that affected the ratings, but that other features such as year and budget were. This lines up with another analysis we did in which we explored the popularity of movies by the top actor or actress. This means that whether you are a male or female based on our analysis, you can still be loved by your viewers. Due to time constraints, or else we could also dive deeper and look at how gender affects the revenue, the box office, and the popularity of the movies in different genres. Thank you.
Great, thank you, Team 3. That was great in time and very interesting. So if people want to take some notes about that presentation, that would be great. Look at those virtual applauses. I will do one as well. Thank you. Okay, great. So the next team that's coming up is Team 7. So who's the presenter from Team 7? You can go ahead and unmute yourself and share your screen.
Hi, my name is Neeraj Kumar. Sorry, I'm not sharing screen yet.
Great.
Hi, our team was Team Seven. This is our team numbers, and this is our analysis for the Movie Lens dataset. So what we did is we wanted to look at three main aspects for movies and the users from this data set. So the first thing that we looked at and found was we looked at certain genres and how they correlated to how high a movie was rated. Then we looked at the user behavior and see the users and how much they rated movies and how their ratings tended to differ when they rated movies. And then we pulled a third data set from TMDB or from Kaggle, and we merged it to the ratings data set to find how ratings affect or the correlation between ratings and revenue that they generate for a movie. So for this slide, we explain the data in terms of ratings for each movie, specifically that of genres and tags for each movie. In genres, we observed that categories such as war, documentary, film, and others which tend to be linked to intellectually deep or rely on technical aspects of filmmaking, they tend to be more higher rated, while genres such as action, horror, and comedy tend to be rated lower because they are seen as lacking in creative substance. And this is corroborated by we did a word plot for the tags rated to, linked to high rated movies, and tags for high rated movies tend to be associated with tags for lower rated movies tend to be associated with cheap thrills such as violence, nudity, horror, teenager, and tags for high rated movies tend to be associated with like deeper aspects of filmmaking such as philosophy, recognition, awards, and this is more common in genres such as war and documentary films. For this slide, we analyzed user behavior. And for this, we found that we analyzed basically the amount of movies that each user reviewed. And we found a majority of the users actually reviewed somewhere between 20 and 200 movies. But there were about 12 that rated over 1,000 movies. So because of that, we had to normalize our distributions and make the x-axis logarithmic so it looks a little neater, because a majority of the users actually rated less than 1,000 movies. And in this top left plot, it shows that a majority of the users, the more movies that a user tended to review, the lower their average review was. And there was basically a very big statistical correlation between the number of reviews that a user does and the average rating that he gave. And then in our bottom plot, we were looking at basically the year that a movie was released and how many reviews, how many ratings it gets. And we found that there was a really big spike in movies released after 1980. It was almost a 3-time spike. And we tend to assume that maybe it's because people are more they're more they know these, they're more familiar with movies released after 1980, or maybe they just prefer movies released after 1980. For our final analysis, we looked at box office revenue for these movies and based on their ratings, and we found that in general, the trend is that higher rated movies tend to have a higher box office revenue, but the only exception is this lower tier 0 to 1 that seems to have a high box office revenue despite being a low rated, having a lot of low rated movies in that category. So, and we're assuming that it might be because a lot of movie companies release movies that make a lot of revenue don't always
1 minute.
Okay, they're not always correlated to their rating. Movies, big box office movies such as Fast and the Furious, Planet of the Apes, and other movies, they're more geared to just making money. So our main conclusions are movies that were highbrow or associated with highbrow, like drama and documentary films, tended to be rated higher. User ratings and their number of reviews tend to have a negative relationship, and that the more movies that a user reviews, the more he tended to give negative reviews, and the movies tended to be more recent films tend to be more popular. And also in general, movies with a higher rating tend to make a higher box office rating, with the exception of the categories of 0 to 1, which had a very high revenue. That was the exception to the rule, more to the case. So that is our presentation.
Great. Thank you, Team 7. Appreciate it. The next team is going to be Team 4. And then on deck will be Team 1. So Team 4, great.
Hi, can you hear me?
We sure can. Thank you. So and Team 4, just I don't see it on your slide here, but just everybody, this is Team 4 that we're going to be seeing here. So for your notes, thank you.
We're the directors, and for the OCRUG Hackathon, we would like to present a story. In a time during a COVID pandemic, one group saw life through a new lens, the movie lens, featuring Erica, Hagen, Joseph, and Randall. How many of you have ever been touched by a romantic comedy? If so, then you're probably familiar with the movies listed on this slide. Movies that's touched your heart and made you cry, or made you cry because you laughed so hard. Who could ever forget in The 40-Year-Old Virgin, Steve Carell getting a wax and becoming a man-o'-lantern? Or in The Princess Bride, when Wesley melted your heart every time he said, "As you wish." It was for these reasons that we took a deep dive into rom-coms to share some insights. And what we found is that 52.3% of rom-com releases have come from the 21st century. And the other 47.7% came from the 100 years prior. And that led us to think, wow, that's a big shift over the last 20 years. So why do we feel like this is happening? We decided to take a step into the rating proportions to see if that could help us clarify this question. And so we broke these years into buckets of 20. Given that the 21st century was over the last 20 years, we could then see 1980 through 1999 and so forth all the way to 1900. And what was interesting is that even though 18.97% of rom-coms came from the 1980s to the 1999s, they made up 56.8% of all ratings. And here we have the distribution of what the ratings look like for all movies. And these blue areas are the proportions that are actually filled by this time frame from 1980 to 1999. So we're definitely seeing people having a lot of opinions during the films released at this time, which then, again, stroke our curiosity. Why is this happening? We decided to take a next step into the words. And the words was interesting because "the" happened to be the word that was used most in all movie titles. I can't have the Beatles without the Beatles, I guess. So with the same thing with rom-coms, you got to have that word "the" in there to really send home the message. But we decided to analyze that by taking that word out to see if we could focus more on what other words were really being emphasized. And in the titles, it was no surprise that the word "love" was the most used word. Then you had "story" and "last" and "night" and "from" and "girl." Words that were tending to lean more towards the romance aspect of the rom-coms. But then we started to take a deep dive into the tags to say, okay, well, how about what are the words being used within the tags? And the words within the tags were going in a different direction. They were going towards the comedic aspect. They focused on the comedy, the quirky, the romance, of course, being there, but funny sticking out, surreal, bittersweet. And as our team put this together, we definitely saw that titles and tags were sending different messages. Rom-com being holistic, it's not surprising, but that brought us to our main conclusions. It's that from 1980 to 1999, more reviews in this era implied that rom-coms inspired greater opinions, despite the large number of rom-coms that appeared in the 21st century.
1 minute.
And when it came to funny versus love, the tags implied that viewers tended to resonate more with the comedic scenarios than the love scenes, despite the titles focusing on the love aspect. So moving forward, our team feels the next best steps is that we should be taking a psychological analytic perspective on how to move forward. That concludes our presentation. Thank you.
Great. Thank you very much, Team 4. All right. Our next presentation is going to be from team number 1, and then that's going to be followed by team number 5 on deck. Great. Thank you.
Didn't unmute myself. Hello, everyone. And this is the presentation of team 1. We are presenting data for movie links about ratings. This is from Sami, Sergey, Caesar, Kevin, Hui, and David. What we have for you today is the information about 9,000 movies, 100,000 ratings, and 600 users. We prepared predictive model. We prepared application for this model, and we have some insights also. For first, we have to present the popularity of the ratings by genre. This is represented by size of the bubble on the left, and action, comedy, and drama seems to be dominating this. And this small bubble in the middle with the highest rating is film noir, and that seems to be the most liked model with highest rating movie. For the time scale we have, there's some unusual interesting tendencies that people who like to rate for the movie a lot, they usually rate it lower for the average rating. So people, that is presented here in horror and romance genres. For our regression model, it was the cumulative logistic regression. We are predicting rating of the movie by its genre, and here is presented the several of results for the rating 4 and 5. Some combinations a little bit strange, but it might be a good idea to make a movie with that. For we combined the defined users with as a fan of the genre by selecting users who reviewed a lot of specific genre. And here you can see that again, the people who reviewing the genre the most, they doing it critically towards their favorite genre. Film noir is doing okay for this as an alternative, if you can suggest alternative to favorite genre. Documentary, as one of that example, has fairly the same rating as the average for the fan of the genre. And for the model, we might say the accuracy for the model is 25% on the rapidly developed model. You can see the link for the app here and check it out. That's it for our presentation.
Okay, great. Thank you, Team 1. The next presentation is going to be Team 5.
Hello. Give me just a second. Let's see if I can find the doohickey. There it is. All right. Can everybody see my screen?
Yep,
And you can all hear me.
we sure can.
Hello, everyone. I'm Kalika Curry with Team 5, and we are going to discuss what I've learned or been experiencing with the Movie Lens dataset. So I was doing the data cleaning on this thing, and what I realized is that one person out of a population actually labeled Plan 9 from Outer Space as bad, but rated it as a 4. And it got me thinking, why is that? Why would you say it's bad, but give it such a high rating? And so I gave it some careful consideration. And I started thinking about those movies that are typically known to be bad movies that everybody loves. And when it comes to a rating system, we start thinking about, how am I going to rate this thing so that I can get more movies that are like this movie, but they're kind of bad, but they're kind of good, but we all know they're bad. And how do I continue to communicate that, yes, this is a bad movie, but you got to see it. So this is how I came to the conclusion, or to move on. I went into looking at some tagged bad movie ratings. So what we're looking at is just a nice little box plot of the movies that were tagged as bad, and we're pulled out with a genome rating of having a 68% match as being relevant. And we took a look at users who submitted 3,000 or more reviews, and this was just to drill down the data set a little bit. I found that the average ratings were about 2.94 for these users. And what we're looking at right here is just, what the average rating looks like for your bad movies, or at least labeled bad movies, right? These are movies that people tagged as so bad it's good, or it's a bad sequel. So, and you can see here, like, you got one here, it's so bad it's funny, and it's got like a label 5 rating. Okay, so how am I going to recommend movies like this? I mean, where am I going to find them? And so we're going to scroll down a bit, and we're going to say, maybe I'm looking at it wrong. Maybe I need to look at funny movies. So this is what it looks like when you decide to look at funny movies. You can see that, you got an unintentionally funny movie. We have one of them, but it's rated as a 4. You've got your very funny movies. You get 77 very funny movies, and they're 2.95. So there's really doesn't appear to be much of a, I guess, feel for who's going to be the worst movie or the funniest worst movie. What I found was that I was going to just take a look at 3 of these categories, and I just pulled out so bad it's funny, dumb but not funny, and unintentionally funny. And when I looked at dumb but funny, it looked like a lot of those movies were just dumb. So I crossed those out, and I decided to just look at funny and unintentionally funny movies. So we scroll down a bit, and we see these are our must-see movies. We got a total of 52 of them. They are all, like I said, with a greater relevance of 68% or greater as far as our movie genome relevance score is concerned. And they are sorted by genome score. And if you look, you can actually see some of these are rated as low as 0.5. Huh, interesting. Anyway, Now I'm curious to see what the data is going to look like after doing a little bit of topic modeling. So that's what I'm off to do, a little bit more analysis and learn more a bit about the data. And got some questions that I'm asking, but mostly just want to do some topic modeling and maybe get a prediction model going and see if we can predict what kind of movies I should be recommending. Thanks, guys. This is Kalika Curry, Team 5 on the Movie Lens data set.
Thank you, Kalika. Thank you, Team 5. Okay, our next team up is team number 2, and that will be followed by our last team, team number 6. So team number 2, if you can unmute and get your presentation ready. Great, thank you.
Sure thing. Can you hear me?
Yep, we sure can. Thank you.
Okay, let me just put this in a... Okay, so we're team 2, team AKR. And so at first we wanted to, create a recommendation system, and we were looking at using the factorization machine algorithm. But then we quickly realized that, this requires a tremendous amount of feature engineering and also an extremely large, you have to make a really large sparse data set, and it just didn't seem feasible. So then we kind of went to, well, can we predict ratings based off of, what genres a movie might be in? And we tried a bunch of different algorithms and different things, and we didn't really get any satisfactory results from that. So instead, we looked at trying to find interesting insights into the data. So we used correlation to find which genres tend to be produced together. And so here in this first graph here, the size and color of each dot represent the correlation coefficient with only significant correlations displayed. This is in the leftmost graph. And so we found that documentary films are not positively correlated with any other genres. And in fact, documentary is one of the top 10 genres with the most number of movies in the single genre category. And you can kind of see this in that rightmost graph. So then we wanted to see which genre is most favorably reviewed in the single genre category by looking at average rating for all the movies with 3 or more reviews. And documentary films seem to have the highest average score compared to other single genre movies, suggesting that there may be some confirmation bias for documentaries. And so now, in this next slide, we wanted to ask if more niche movies will result in better reception from the reviewer. So to answer this question, we specifically looked at 2 genres: drama, because it's one of the most top produced genres of films, and animation, because animation is rather a film medium than genre. And we calculated the average ratings of movies with 2 or more genres and whether they have positive correlation, negative correlation, or no correlation at all with drama or animation. And interestingly enough, while negatively correlated dramas performed worse than positive and non-correlated dramas, the same cannot be said about animation. Negatively correlated animated movies perform slightly better than positive or no correlation animated movies. And we think this perhaps might be due to most of many Western animated movies in this data set are correlated with the children category, and reviews tend to be from adults who have different tastes from children.
You're going to get.
And finally, for this next slide, we're doing comparisons of ratings across different timestamps or when the movie is released. So in the top left, this shows movies ratings for every 5 years, like movies from 1990 to 1995, that would be one category. And what is the average rating? And then in the other 3 graphs, we're trying to see patterns in what the average rating would be when a person reviews a 0-year-old movie, or a 5-year-old movie, or 100 or 10, and so on. And specifically for the bottom left, we did this for Gattaca, and then the top right, we did this for Forrest Gump. Forrest Gump being the most highest reviewed movie, and we particularly picked Gattaca because we were interested in that, because there's, I guess, folklore that perhaps the movie was not originally well liked when it originally came out, but more recently, due to what's going on in the world, you know, as of recent times, that perhaps the movies has been getting a lot higher ratings. But however, you know, looking at the graph, there's not much to argue to, you know, defend that folklore, as you can see that, you know, the more recent reviews were not, you know, more favorable than the past ones. And yeah, and that's it. Thank you very much.
Great. Thank you very much, team number 2. And for our last team is team number 6.
Sorry, can you guys hear me?
Yep, we sure can.
Okay,
Thank you.
cool. All right, start right now. Okay, hi, my name is Brian, and here are team 6, along with Ellie, Hafsa, Jay, and Jane. So what's next? Oh, in the past, we have watched most of our favorite or best movies on the streaming service or from the cinemas, or as well, even watching, you know, renting a movie from Blockbuster back in the day. So, but with the pandemic going on, not much movie are being produced for health reasons. And then as a result of that, many cinemas are facing bankruptcy during the pandemic and are eager to generate more revenue when things are hopefully come back to normal sooner. So our key question regarding to this movie lens data is, what genres of movies should we recommend to customers as they start coming back to theaters? So we've simply focused on the ratings and movies data set. So on the top right histogram of the movie rating, you can see the distribution of the movie rating is leftly skewed because we noticed that some movies get more ratings from people than others. So that creates some imbalance in our movie rating. So to solve that, based on the formulation from IMDM's formula right here, the weighted rating, this helps us to normalize the data. And as you can see on the bottom right, our movie weighted ratings is more normally distributed. So this pretty much linear regression model where our response variable is the weighted rating, and our independent variables are mostly genres that are binary. So this is a model that we just simply explore and see what genres pretty much contribute to movie ratings. So as you can see, like the top 3 variables are the IMAX and IMAX, drama, and sci-fi that you can see are associated with a higher rating, especially for IMAX, which is show a coefficient of 0.06. So this ties up to the movies that top 10 movies out of 2010. You can see Inception, Shutter Island, Interstellar, and Guardians of the Galaxy. For sure, those movies were in IMAX and considered to be our top blockbuster movies that most people go to the cinemas. That could also mean that like customers are looking for a greater movie experience if the movie is in IMAX. So according to our model, that IMAX is an important feature in highly rated films. So, but the question is like, can higher rating potential be associated with increase in revenue? We're not 100% sure, since the analysis is limited and there are other factors that could contribute to ratings in general. So since the data set is limited and we need more information to put forward for this project, movie theaters can do more research on whether customers prefer IMAX movies or IMAX tends to select film based on their potential for popularity. So this is concludes our presentation.